So we didn't have a chance to collaborate with any other teams. We tried to get in touch with a team from Australia that was doing Spot the Station, but we got stymied by the time difference. They reached out to us while we were all asleep, and then we got back to them when they were all asleep. Are we ready to go?
Not yet.
Okay. So I guess I'll start the presentation and then talk about our team members once we have it up on the screen. So our team is called ISS Base Station. It's not Space Station, that sounds like it. We were working on the Spot the Station project. So the idea of the Spot the Station project is to take this data that NASA has about when the ISS space station is over a certain area. And the challenge was originally to sort of build on this, build some kind of app, make it a little more interactive, and one of the more important things was use social media to bring together people who were interested in the space station, interested in space exploration. And we thought, social media is cool, but what's even cooler is bringing together people in real life who are passionate about space exploration, who care about the space station. So we envisioned sort of hypothetical, ideal, sort of public art installation, where you have a statue of a child pointing at the sky. And on the base of the statue, you have a screen that just shows a really simple map of where the space station is at that moment. Sort of a trail showing where it's been and where it's going. And then what gets really exciting is when the space station gets close, sort of close enough to actually be seen, the statue lights up and the child, or whatever we have, points at where the station is going to be. It follows it along the sky. And anyone who's there, maybe it's cloudy, maybe it's dark, maybe the sun is glaring, maybe you can't see the station. So I have a smartphone app. So you can take out your phone, open up an app, point it at wherever this child is pointing, and have an augmented reality screen set up where you can see highlighted where the station is, following along as it points. So what we set out to build was a sort of prototype for this kind of installation. You go to the first slide real quick so I can now introduce who we are. So we are a gigantic team, pretty much this half of the room. More or less split into two sub-teams. I'm Dan, I sort of managing the project. We have on our hardware team Ryan, Elaine, Himavath, Andrew, David, and Ivan. We have Elaine and Himavath up here. And then for our software team, we had Daniel, Patrick, Samir, TK, Matt, and Nina. Daniel's right here, Patrick's right here. Matt is our guru on AirPlay. So yeah, we're just going to take a minute to talk about those subcomponents of our project. So first, I guess when we have Daniel and Patrick talk a little bit about the mapping portion.
Okay, cool.
Okay. So the mapping course is just like a very simple ISS tracker. We show a map and we show where the space station is at this current moment. And if we zoom out far enough, you'll also see the location of our base station, which is essentially where we are right now. So if you wait for a long time, it'll start leaving more red dots, and it'll show you the trail of the path of the space station.
Yeah, right. So basically, we just built a map in the map box, and then pulled in. We built a node service. It works with a very, very simple node server, and all we do is use leaflet.js to draw the map and put things onto the map, and it updates every 5 seconds.
And then we added an augmented reality portion of it. So if you look here, the idea of this is if the International Space Station is close enough to you, you could actually turn around and try to find it.
Ooh, there it is.
It uses the gyroscope on the iPhone, and it actually gives position the azimuth of the space station relative to where you are. And then we're hoping to get the degree of altitude so you can look up and find it. And then from here, so for somewhere outside, we're like, oh, there's a space station. We have the ability to take a picture of it, pretend we're not inside. From here, we can actually tweak our picture. We have a hashtag already set up, ISS Philly, so we can go ahead. Here's the station.
And you have to tweet like in the angle that you are taking the photo.
So now I've tweeted, here I am looking at the station, but we're hoping that we can use this to encourage a lot of people who are, who might be looking for the International Space Station in the same area to find each other through Twitter.
So I guess now we'll talk a little bit about the hardware portion.
So another major component of this was the hardware, the child actually pointing a good device. And here we have some kind of simplified access system. And we use continuous rotation servos connected to Arduino with an Ethernet shield for you techie people out there. And what we do is we get requests from service. You'll push these requests here, and then our Arduino will be able to parse these commands into two thetas. That'll tell us how much we need to rotate to get the orientation of where the ISS is. And so if I hook this up right now, I have a sample code that basically just does 90-degree rotation. And this is just to show that we can actually do this given certain thetas. So this will rotate around some 90. Using better hardware, more precise hardware, we can get really close to where we actually want to point. And then, these web services will just push data to us, which we can use later to not wrap around ourselves.
So,
Unless you want to introduce it to teams.
So real quick, Node.js, Leaflet, any other open source stuff you guys have?
We had Leaflet library as well for
AF networking for iOS stuff.
So we use a lot of open LED matrix things to interface with other hardware. That was just all open source.
Yeah, make your work this weekend easier. It's all these open source. And all our code is on GitHub. We have 3 separate repositories.
3 separate repositories, largest team, youngest team member. A lot. Was he gonna? Yeah. Was he? Yeah. Can you share it? This is a little bit outside the prize structure, but go ahead and tell us what you're working on.
Okay, so over the course of the weekend, I worked with Aline and Kai over there on the hardware portion, and we had a lot of problems. I mainly spent my time building the K'NEX and learning about how they were working with the Arduino control system. And we had a lot of difficulties with actually making the K'NEX fit together. And it's not really the best fit. I mean, the servos are held on by duct tape at the bottom. And
hacker cred.
This whole thing can shake around and do things, but if we continue with this and we make it a bit more high quality materials and motors and things like that, it can be a lot more durable, and user interface will be a lot better.